to the foundation models for language, we have a foundation model for time series. The authors named it TimeGPT. As you can imagine, the model has been trained on vast time series datasets as a large transformer model. Here they provide the architecture which is similar to LLM's transformer architecture. And the interesting thing is the results are quite impressive, beating the state-of-the-art models, including DeepAI from Amazon. All right. So all these results are zero-shot results, meaning we still use the historical data to make the forecasts, but we don't train or fine-tune the model. Okay. Similar to the LLM foundation models, the next word is predicted based on the previous words in an autoregressive way, right? Similarly, we make the forecasts without fine-tuning or retraining the model. So that's what zero shot refers to in time series context. Okay. So here, these results, the authors say they compiled on 300,000 unique time series, and the results using this model are quite impressive. Okay. So I'll provide the get link in the description, but let's see how we can use this model. All right. So the library name, it's called this Nixtla. You can install using pip. Now, the exogenous variable, it's simply a fancy name for feature variables in a machine learning sense. Okay. So you can sign up, get the free API key. All right. Initialize the client, and here we load a data set. Okay. So this is the electricity prices data set. So here the Y, it represents the prices. Okay. And we have the timestamp as DS. So as you can see, this is hourly data. So it's on the same day. We have a time 0, midnight, 1 a.m., 2 a.m., so on and so forth. Okay. And we have this unique ID. You can think of it like a city. So here basically we have the electricity prices from 5 cities. So here we have two exogenous variables. I mean, just some features. You can think of it like maybe the demand and supply. Okay. So how does the price vary according to the demand and supply? And then we have 7 additional features, just representing which day of the week. Okay. So for example, Sunday is 0, Monday is 1. So as you can see here, only one of the variables has this value equal to 1. Okay. Because these are all representing the same days, these 5. So it's day 5. Okay. All right. Okay. So this is the historical data we will use to forecast for the following, let's say 1 day or 24 data points. Okay. So when we do the forecast, we need to supply our features, right? Similar to in a machine learning model. Now, one interesting thing and confusing thing about time series is when we have features in a time series data and we forecast the future, we need to know the feature values for the future time period, right? Then only we can plug these values to make the forecasts. Okay. Unlike in a machine learning use case where all the features are available at the time of the prediction, in a time series forecast, we might not have all these features available at the time of forecast. Okay. So in order to forecast, we first need to forecast, or in some cases, we first may need to forecast these variables and then use those values to forecast our target variable. Okay. That's one very important differentiator between a machine learning model and a time series forecasting model with respect to the features. All right. So here we have the future data. All right. So as you can see here, we don't have the target variable. So we have all the features. So let's, for a moment, let's assume all the features are readily available. We will see in a minute how to handle if we don't have all these features values available for the period we are trying to forecast. Okay. All right. And it's a very simple API. The authors have abstracted pretty much all the details. So it's a very high level API, easy to use. All right. So using the client, we call the forecast method. The first variable is the historical data, which is this data frame. And then the future feature values, we supply them as a data frame, which is called this XDF. So this is like feature values at the time of inference. Okay. So which is simply this data frame. Okay. So it's this data frame. And so we are forecasting for the following 24 points. And then we can also specify the confidence interval so that we have the errors in the forecasts or the upper and lower bounds. Okay. All right. So it written another data frame with the forecasts. So this is how it looks like. So these are the feature timestamps. TimeGPT, this represents the forecast. So here we have the actual forecasts. And then for the 90% confidence interval as well as for the 80% confidence interval, the upper and lower limits. Okay. All right. So if we want higher confidence, obviously the upper and lower bounds, the range will increase because we want to be more confident. So that's why it will increase. So if you look at the lower bound, so for 80%, so it's 64, whereas for 90, it's 60. So the lower bound has further dropped, and whereas at the upper bound at 90% confidence interval is higher than at 80% confidence interval. Okay, that makes sense. I hope you get that point. All right, and then it has a lot of these convenient functions to do the visualization as well. So we just do the plot, and here we are plotting for each unique ID, which we can think of as a city, the timestamp, and the historical values as well as the forecasts. Okay, so here we have the historicals, the pink one, the forecasts, and we also have the 80% and 90% confidence interval. So the 90% one, it's very light pink. I'm not sure if you can see clearly, but these values, the range is broader compared to 80% confidence interval. This is looking nice. And remember, we have not trained the model here. Through the historical data, we are using it in this auto-regressive sense. We haven't trained or fine-tuned the model. Okay, that's why it is the foundation model used as it is. Now, obviously, how we train, how we can fine-tune this llama, etc., the language foundation models, the TimeGPT also we can fine-tune on our data to improve the accuracy further. But all these results are without fine-tuning or retraining the models. All right. Another convenient function, we can look at the important features. So as you can see here, the exogenous are the features which are named as exogenous. These are very highly important as compared to which day of the week. Okay. I mean, again, let's say for electricity price, the supply and demand drive the price as compared to which day of the week. Okay. All right. And then, as I mentioned, the tricky thing with time series is when we do the forecast into the future, in most scenarios, we will not have these exogenous variable values, right? So how do we handle? It's very simple. First, we make the forecasts of these variables, and we supply the forecasts when making the forecasts of our actual target variable. Okay, that's what we are going to see here. All right, so it's the same data set, and here we have created two data frames with timestamp and the feature 1, and similarly timestamp and feature 2. So we are going to forecast the feature 1 and feature 2 values into the feature, and then use those forecasts as inputs to our final model. Okay, so we are forecasting the historical data for the next 24 data points, or for the next 24 hours. Okay, all right. And then once we made the forecast, we are going to construct a data frame similar to this one, right? So all we have is, we know the unique ID, we know the timestamp, and we know the historical values. So we have just forecasted this exogenous 1 and exogenous 2 for the following 24 data points. Okay, so we combine them to make a data frame with these 4 columns, and then we will figure out how to compute these values. We add them to the same data frame. That will make us the features data frame for the forecasting. Okay, all right. So once we have forecasted these two variables, we rename them, because this data frame contain the forecasts as TimeGPT, right? Similar to what we saw here. So this is the forecast TimeGPT. Okay, so we rename the first one to exogenous 1, the second feature to exogenous 2, and we combine these two data frames. So this is the result. Okay, so for the future time period, we have forecasted these two variables. Okay, and then as I mentioned, all these variables are simply representing which day of the week. Okay, so we can simply compute using the weekday. Okay, so we just loop over the 7 days, and we will check which day of the week it is, and that will be 1, otherwise it will be 0. All right, so we added these 7 features also to the data frame. Okay, so this is our XDF. So all right, so we have prepared a data frame which is similar to this one here. Okay, so when we use features in a time series forecasting model, when some of these features are not available, we can use the same time series modeling to forecast those first, and then feed them as features to our final model, which is exactly what we have done here. Okay, so once we have this data frame, this is the original data frame. We read it from the source. As you can see, these two are different. So it's for the same unique ID and the timestamp. Here, these values are the forecasts, whereas these values are the actual ones. Okay, obviously the forecasts are not exactly equal to the actual ones. All right, and then using these forecasted values, now we are forecasting the actual electricity price. Okay, so here is our forecasts, and similar to previous, we have this 80% and 90% confidence intervals. Okay, that's pretty much it. But here we are just comparing compared to the actual feature values, how the predictions or the forecasts change when we use the forecasted values for these two input features. Okay, so that's what we are looking here. So we just combine these two data frames and we are plotting them. So our historical data, and then the yellow one, that's with the actual exogenous variables, whereas the pink one is first we forecasted the feature values and then fed them to forecast the final target variable, which is this pink one. As you can see, these are not, there is clearly differences. That's because again the input features are different. Okay, but anyway, so as you can see, it's super simple. It's a very clean API. Yeah, I thought this will be interesting for you. Thank you very much. That's it for this video.